mixed one, so that at least we now cover the syllabus in a way that you are ready for your exam. Note, it will be very, very wrong to go through mixed examples when you have not gone through the course. If you have gone through the course and you are now going through past questions like you normally do, or mixed examples as I've been taking here, you will find it more interesting, less boring. Please complete your syllabus and then you'll be ready to practice mixed examples. Number 1, write 1, 2, 2 base 10 in base 2. Very simple question, but I will have to remind you of what you did during the course. It is okay to do the successive division and collect your result up. That is, you go through 122, you have 2 in that, 61 and so on, plus 0. But that method we agree is too long. For base 2 to base 10 or base 10 to base 2, just use direct conversion. And what is direct conversion? You use powers of 2. If you look at 122, the highest power of 2 you have is 2 raised to power 6, which is 64. Again, you have to make up a table of powers of 2. 2 raised to power 0 is 1, 2 raised to power 2 is 2, 2 raised to power 2 is 4, 2 raised to power 1 is 2, 2 raised to power 2 is 4, and so on. You make a table of powers of 2. Well, if you want to quickly remind yourself of that, 2 raised to power 0, 1, 2 raised to power 1, 2, 2 raised to power 2, 4, and 2 raised to power 6 is 64. Now, obviously, 2 raised to power 7 will be 128, and we only have 122. So the highest power of 2 we have is 2 raised to power 6. Now, if you remove 64 from 122, you'll be left with 4 from 12, 8, 6 from, you have borrowed 1, 6 from 11, 5. Again, you ask yourself, what is the highest power of 2 you can get in 58? Looking at the table, you can get the next power of 2, which is 32. If you subtract 32 from 58, what do we have now? 6, and then 26. Once again, the next power of 2 is 16, so you can still get 16, you'll be left with 10. You can get 8 from 10, you'll be left with just 2. So what you do is you write your 122 as 64 plus 32 plus 16, which will leave you with 10 plus 8 plus 2. Break your figure down into powers of 2. And now, the implication of this is you have 2 raised to power 6, 2 raised to power 5, 2 raised to power 4, and 2 raised to power 3, and finally 2 raised to power 1. And what you have to do is you start from the highest power of 2 and write for every bundle you have 1. Every bundle missing, it's a 0. So we have now 1 bundle of 6, and the next thing after 6 is 5. You have to go in descending order of powers. 6, 5, yes. After 5, 4, yes. After 4, we have 3, that's a yes. After 3, the natural thing is 2. The 2 raised to power 2 is missing. Therefore, we have to keep that position with 0. There is no 2 raised to power 2. After 2, the next one is 2 raised to power 1, which is a yes. And finally, we stop at 2 raised to power 0, which is 0, because there is no 1. And so 122 base 10 122 base 10 is 1111010 base 2. Number 2 is asking you now to convert from base 2 to base 10. Again, you use exactly the same method, the direct conversion. It's easier to do this. Please learn it. I know some of you will say, oh, I still prefer that successive division and multiplication. It is not necessary. If you look at what you have here, you start from power 0. That's 2 raised to power 0, 2 raised to power 1, 2, 3, 4, 5, 6, 7. And the beauty of this is that all you have to do is pick only where there is 1. What power of 2 you have. All the zeros mean they don't exist. So it's 0. So here we have 10101 is 2 is equal to 2 raised to power 7 plus 2 raised to power 6 plus there is no power 5, 2 raised to power 4 plus no power 3, 2 raised to power 2, and finally 2 raised to power 0, which is 1. And then again, if you like, draw up your table of powers of 2, which you already have. 2 raised to power 7 is simply 2 times 64, which is 128. And so you have 128 plus 2 raised to power 6, which is 64, plus 2 raised to power 4, which is 16, plus 2 raised to power 2, which is 4, and then plus 1. Now, if you add this up, you should get 213. 213. And that answer is 10, which is not, you don't have to write the 10. It's a binary system. Number 3 would like us to compute the sum of binary numbers. It's again very, very simple. The same method you use in addition, starting from the unit position, you work backwards. So let's start from here. 1 plus 1, 2 plus 1, 3. Now, the question now is, from your 3, how many bundles of 2 can you get? Of course, 1, 2, and you're left with 1. So you write 1 and you carry 1. Then 1 plus 0, 1 plus 0, 1 plus 0, 1. So you have a 1 again. Then we go to the third position. Here 1 plus 0, that's 1, plus 1, that is 2. Now 2 in 2 is 1, remainder 0. So you are left with nothing. And now you carry 1 bundle to the fourth position. 1 plus 1, 2, plus 1 here, 3, plus 0 here, another 3. How many 2 can you get from 3? 1 remainder 1. You write the remainder, you carry the bundle, which is 1. So you now go to the fifth position. So 1 plus 1, 2. 2 plus 1 here, 3. And so again you have 1 remainder 1. That 1 plus nothing, it's 1. And so the addition is really, really very simple. Just remember to carry the bundle you are counting in. Number 4 is we are being asked to solve equations. And if you look at that question, you have a fractional equation. So what is the first step to take when you are solving fractional equation? I hope you still remember. Get rid of the fraction. You get rid of the fraction. But here, we also have an additional problem. We are given a mixed number, which is not the usual way a fraction is supposed to be expressed. So we don't want a mixed number. We change it to improper fraction. I hope you got that right. You change this to improper fraction. That is, this equation will become r minus 1 over 2r plus 1 is equal to, now, 2 bundles of 3s, because this denominator being 3 implies that your whole bundle is cut into 3 parts. So if you have 2 whole numbers cutting into 3 parts, each will give you 6 parts. That's 2 times 3, 6 plus 1, giving you 7. So this is 7 over 3. And now, there are 2 ways of looking at this. You could say you cross multiply. That is 3 into that is equal to 7 into that. Or you could simply write the usual step. Multiply through by the LCD, the lowest common denominator, which is 3 into 2r plus 1. 3 into 2r plus 1. Now, if you cross multiply, you still get the same answer. Here, if you multiply this fraction by 3 into 2r plus 1, 2r plus 1 will cancel. You'll be left with 3. And then 3 will have to multiply the numerator. Therefore, you have 3 into r minus 1 is equal to, now here again, if you multiply this fraction by the LCD, 3 will cancel, you will be left with 2r plus 1. So you have 7 times that is equal to 7 into 2r plus 1. And now, what do? Remove brackets. Remove brackets. And so we have 3 times r, which is 3r, and 3 times minus 1, which will give you minus 3, is equal to 7 times 2r will give you 14r, and 7 times plus 1 will give you plus 7. Now we have a situation where everything is all mixed up, and we transfer. Now note, I have explained this before, transfer simply implies add the additive inverse of whatever you don't want to get rid of it to both sides of the equation. We want all letters on this side and numbers here. That is the major aim of solving an equation. So transferring here will imply get all r's together and all numbers together. Also, there is usually this feeling that you try as much as possible to maintain a positive unknown, so that in your working you don't get confused, because most people cannot deal with negative numbers. So I'm going to say 14r minus 3r is equal to my minus 3 minus 7. Or I could say 3r minus 14r is equal to 7 plus 3. Does not really matter which one you pick first in this case. So we have 3r minus 14r is equal to 7, which is positive. Now please write what you have on this side first before bringing in whatever you are transferring. So the minus 3 becomes plus 3 on that side. Now we collect like terms. We collect like terms. So 3r minus 14r will give us minus 11r, which is equal to 7 plus 3 as 10. And now we divide both sides by the coefficient of r, which is minus 11. Therefore, our r is equal to 10 over minus 11, which is simply negative answer, which is equal to minus 10 over 11. Now, one thing you have to note here, you have 3r minus 14r, and what this implies that you have 3r, you are owing 14. You have to pay with what you have, and you still be owing 11. So just balance off. Whatever result result you have. It could be positive, it could be negative. Just take one away from the other. Give the sign of the bigger one. Number 6, we'll now take